Myself, Dr. Sadhna Singh. Last time we studied in the structure of atom, Sommerfeld model, and now it is de Broglie. The next is de Broglie model. The de Broglie model is about the dual nature of matter. After the quantization theory, which says that the energy of radiations are in the form of bundles, which are called quanta or photon, and the nature of radiations is a wave nature. Thus the radiations or the light have wave as well as particle nature. The particle characteristic of radiations or light is proved by photoelectric effect and Compton effect, and the wave characteristic by the properties like vibration, diffraction, refraction of light or radiations. Thus, the radiations or light have a dual character, a wave character as well as a particle character. Now, on the basis of this dual character of radiations or a light, in 1923, de Broglie also assumed that the matter or the particles like electron, proton, etc. may have a dual character. With particle character, they may have wave character. He said, in Bohr model of atom, n is used as a whole number and n is used as a whole number, and n as a whole number is used for the study of wave properties like vibration, refraction, diffraction, etc. Thus, on the basis of this, de Broglie says that electron, proton, neutron and the other particles, they also have wave character with a particle nature, and when the electron is moving, he said that waves are associated with it, and on the basis of this wave character, the wave mechanics is developed. So, the de Broglie assumed that the particles may have a wave character with a particle character, and to justify this wave character, he has derived an equation which is known as the de Broglie equation. For the derivation of de Broglie equation, the de Broglie uses the two equations, the Planck equation and the Einstein equation. The Planck equation is the E is equal to h mu, where h is a Planck constant and mu is the frequency of a photon, and the Einstein equation is E is equal to mc square, where m is the mass of photon and c is the velocity of photon. By using 1 and 2 equation, the equation is equal to, from these 1 and 2 equation, then it is h mu is equal to m into c square. This is the third equation, and in this third equation, if you put the value of frequency, which is equal to c upon lambda, where mu is the frequency, c is the velocity of light and lambda is the wavelength of a light or a photon, then the equation 3 becomes h upon lambda is equal to m into c, or we can say lambda is equal to h upon m into c, or m into c is mass into velocity is known as the momentum. So lambda is equal to h upon momentum, where lambda is the wavelength of moving photon. From by this equation, de Broglie says for a particle, if the velocity is c, if the velocity of particle is c, then the equation 4, that is lambda is equal to h upon mc, becomes lambda is equal to h upon p momentum, and h is the Planck constant. So lambda is equal to h upon m into v, where m is the mass of particle and v is the velocity of particle. So this equation, lambda is equal to h upon p or lambda is equal to h upon m into v, is known as de Broglie equation. This is for the matter or a particle. He said, from this equation, he said, if any particle or a matter which have a mass and velocity and it is moving, which it has a mass and a velocity, then the waves are associated with it and the wavelength of that particle which is moving is equal to h upon p or h upon m into v. He said, in this equation, it seems that the wavelength of a moving particle is inversely proportional to its momentum or its m into v. So if the mass is a bigger mass, then the wavelength associated with that one is very small, and if its mass is small, the wavelength is quite big, which can be considerable. For this, an example is taken. To understand this, an example is taken. In the example, if a ball which is having 100 gram of weight, mass, and moving with the velocity 100 centimeter per second, then the de Broglie wavelength of that ball is lambda is equal to h upon m into v. Lambda is equal to h upon m into v. H is 6.625 into 10 to the power minus 27. Mass of the ball is 100. Velocity is 100 centimeter per second, and the value of lambda is 6.625 into 10 to the power minus 31 centimeter, which is a very small value. And if a particle like electron, small particle like electron, that is minute particle like electron, is moving, then the wavelength associated with it is equal to 3.295 into 10 to the power minus 8 centimeter, which is a bigger value than this one. And this value of electron's wavelength is similar as the wavelength of the X-rays. So this shows that when electron is moving, then its wavelength is quite considerable. So when small particles like electrons is moving, the waves are associated with them, and then their wavelength is also quite considerable. So de Broglie said that the electron or the particles, smaller particles, they also have wave characteristic when they are moving. So, and to justify this, we will study for the justification of the de Broglie model. Thank you.